Welcome to Maths on YouTube. In this video tutorial, we are going to talk about basic geometry. We are going to learn lines, angles, and some basic properties related to it, different symbols that you should know, and congruent triangles, and how we can identify them. So let's get started. So what do we mean by geometry? Some people may recognize this root word geo, which is the same in geography and geology. And this root word means earth. And this metry, we see it in trigonometry and the metric system. And this metry is referring to the measurement. So geometry as itself means the earth's measurement. And this is kind of correct, as geometry really is a study and trying to understand how space and things and shapes that we see are related to each other. Now the first thing we're going to look at is a line. Now what is a line? Many people may think that line is something that looks like this. But in geometry, a line would have two arrows at the end to indicate that this goes on forever in opposite directions. Let's put some points on this line. And now to distinguish between the points, we would label them. So let's label this A, B, and C. Now if you want to call this line, we can call it line AB and put a smaller line on top of it to indicate that it's a line. Or we can call it line AC or line BC. It does not have to start from A. It can start from B as well. Or even C. You can call it CB or CA. But just remember, if you want to name a line, you must include this symbol on top of it to indicate that it's a line. Now what about ray? What is a ray? Well, a ray has a starting point and it goes on forever in the other direction. This is similar to the line, but a line goes on forever in both directions. But a ray, it's only one direction and the other direction has a starting point. Now let's put some points on this ray. We call this point A, B, and C. To name this ray, we write it like AB and we put a ray on top of it without the other arrow like in the line. And we can also call this AC. And note, we cannot call it BC because the starting letter needs to be the initial starting point. And in this ray, the initial starting point is point A. So the first letter must be A. Now what is a segment? What do we mean by a segment? Well, a segment has a starting point and an ending point. We can call this A and B. And to write this segment, we write it as AB with no arrows on it because it does not go forever. It stays as it is. Or we can call it BA. Now let's look at the three things we learned so far. A line has two arrows in it to indicate that it goes on forever in both directions. A ray has a starting point and it goes on forever in the other direction. A segment has a starting point and an ending point. So a segment is just this. It does not go forever. A ray goes forever in one direction. A line goes forever in both directions. Now let's look at angles. There are 6 different types of angles that you should be familiar with. The first one is an acute angle. And an acute angle looks something like this. with an angle measure of, let's say, x degrees. But often when we refer to like degrees, we don't use an alphabet. What we use is something called a theta, let's say. A theta is a symbol like this, which is the 8th letter of the Greek alphabet that we commonly use to indicate an unknown angle. So this acute angle has an angle of theta, and the angle measure for theta for acute angle should be greater than 0 degrees and less than 90 degrees. Now for a right angle, it looks something like this. And this time, we don't draw a curve here. We draw something like a box to indicate that it's a right angle. And the measurement for a right angle is 90 degrees. So theta is 90 degrees. An obtuse angle has an angle measure of more than 90 degrees and less than 180 degrees. So it looks something like that. A straight angle looks like a line, and it has an angle measure of 180 degrees. A reflex angle looks something like this, and it has an angle measurement of greater than 180 degrees and less than 360 degrees. Now a complete angle looks something like this. Now here the angle measurement is 360 degrees, a full rotation. Let's look at one more time. An acute angle has an angle measurement of more than 0 degrees and less than 90 degrees. A straight angle has an angle measurement of 90 degrees. An obtuse angle has an angle measurement of more than 90 and less than 180. A straight angle has an angle measurement of 180 degrees. A reflex angle has an angle measurement of more than 180 and less than 360. And a complete angle has an angle measurement of 360 degrees. Now you can identify this by looking as well. So if it looks something like that, we know it's an acute angle. If it looks something like that, we know it's an obtuse angle because it's not a straight line. If it was a straight line like this would be a straight angle. And if it was more than that, we know it's a reflex angle. And if we see something like this with a whole circle on it, this is a complete angle with the angle measurement of 360 degrees. And if we see something like this with just a box in it, we instantly know that this is a right angle. Now let's look at something called a midpoint. What is a midpoint? Well, as the name suggests, the midpoint is the middle point of a line or a segment. So let's say if we have a segment AB, AC, let's say AC, and we have a point in the middle called B, and B is a midpoint. But what does it mean? It means that B divides the segment into two equal parts. So this and this are equal. When you see these marks, they mean that they are congruent. So segment AB is congruent to segment BC because this is the middle point. And you write it like AB and BC are congruent. This symbol here means congruent. So we can say that as segment AC, that point B bisects segment AC because it divides it into two equal parts. Now let's say if you have a ray that passes through B, oops, like that. Let's name this ray D. So this ray DB is the segment bisector. Segment bisector of AC because it is dividing it into two equal parts, two congruent parts. AB is congruent to BC, and because this ray D is passing through the point B, it is a segment bisector of the line of the segment AC. Let us now look at something called the angle bisector. Now, what is an angle bisector? Well, an angle bisector is a ray that separates an angle into two equal parts. For example, let's say if we have an angle like this, and let's call it A, B, and C. And if we have a ray emerging from B, and let's call this ray BD. Now, the ray BD is an angle bisector of this angle if this angle is equal to this angle. So if angle ABC, by the way, this is how you write angle. You have this angle symbol, and the vertex is all in the middle. So it can be angle ABC or it can be angle CBA. It cannot be anything else except these two. So now let us look at something else. If you have an angle called CDA, to name this angle, we use angle CDA and we use angle ADC. The D is always in the middle because it's the vertex of it. So let's say for example angle ABC is equal to 60 degrees. And if this BD, if the ray BD is an angle bisector, then the angle ABD, this angle, would be 30 degrees. And angle DBC would be also 30 degrees because 60 divided into two equal parts is 30. So this would be 30 and this is also 30. So that is an angle bisector. Angle bisector is basically a ray that bisects an angle into two equal parts. If you have a right angle triangle, an angle bisector would divide it into 45 and 45. And if you have a straight angle, an angle bisector would divide it into 90 degrees. This is also perpendicular that we will be going through later in the video. So let's look at parallel lines now. What do we know about parallel lines? Well, we know that parallel lines, they never intersect, meaning that they would go on forever and never meet. Let's call this line A and line B. Now parallel lines also have the same slope or the gradient. We will learn more about gradients and slopes when we look at linear equations in the future videos. For now, all you need to know is that the gradient of M, and this is how you write it, M is the gradient, and the gradient of A is equal to, let's say, 2. No, that's not right. Let's say example 1/4. and the gradient of B would also be 1/4. So the true properties we know about parallel lines, one is that they never meet. Intersect. Two is that they have the same slope. And to write the parallel lines, the geometric symbol for it, we write it like A is parallel to B. The symbol in the middle indicates that A is parallel to B. Two lines is a symbol for telling people that something is parallel to something else. Let us now look at perpendicular lines and see how they are different from parallel lines. Parallel lines, we said that they never intersect, right? Now perpendicular lines, they do. In fact, they intersect at right angles. Let's say this is line A and this is line B. And they intersect by making right angles here. So perpendicular lines intersect at right angles. And to write this, we write A is perpendicular to B. This is the symbol we use. Now let's talk about slope of this perpendicular lines. If the slope of A is positive 4/3, what do you think would be the slope of B? To find the slope of a perpendicular line, we first flip the fraction and then we change the sign from positive to negative. So perpendicular lines is slope are negative reciprocals of each other. So let's look at one more example. If the slope of A is 6/3, not 6/3, 6/5, what do you think would be the slope of B? The slope of B would be, flip the fraction 5/6 and a negative 5/6. So that's perpendicular lines. They intersect at right angles and their slope are the negative reciprocals of each other. Parallel lines are lines that never meet or never intersect, and they have the same slope. Let us now look at complementary angles and supplementary angles. So what does it mean by complementary angles? Complementary angles are angles that add up to make 90 degrees. So let's say if we have a right angle triangle here, and this is angle A, and this is angle B. Now let's say for instance, we know that this is 50, and we had to find this angle A. Now the sum of a triangle adds up to 180, yeah? So this is 90 and this is 50. So 90 plus 50 plus what will give us 180. So this A has to be 40. And let's name this A, B, and C. So angle A, B, and C is 50, and angle B, C, and A is 40 degrees. So we can say that angle BCA and angle ABC are complementary angles because they add up to make 90 degrees. So because the measure of angle ABC plus the measure of angle BCA is equal to 90 degrees, these two angles are complementary angles. So now what is supplementary angles? Well, supplementary angles are angles that add up to 180 degrees. So let's say if you have a straight line and like that, we know that this angle measure is 130 degrees, and we need to find this. We know that a straight line is 180 degrees. So what number plus 130 is equal to 180? So 130 plus 50 would equal to 180. So let's name this A, B, C, and D. So angle BCD is equal to 130 degrees, and angle ACD is equal to 50 degrees. Now, because of the angle measures of these two angles, the angle measure of BCD and the angle measure of ACD, they add up to 180 degrees. That is why these two angles are supplementary angles. So in short, complementary angles are angles that add up to 90 degrees, and supplementary angles are angles that add up to 180 degrees. So the next geometric term that you need to be familiar with is the transitive property. Now, what is a transitive property? So by definition, the transitive property means that if two angles are congruent to the same angle, then that means that they are congruent to each other. So let's say if angle 1 is congruent to angle 2, and if angle 2 is congruent to angle 3, then this means that angle 1 is congruent to angle 3. Now this seems pretty obvious, but it is good to remember this. Another way you can put it this as by using variables. So if A is equal to B and B is equal to C, then that means that A is equal to C. So this is transitive property, and it's good to put in your notes, which will help you in future when you have complex angles such as like that, and you need to prove something. You can prove them by transitive property. So it's good to remember this. It will come in future. Let's now look at vertically opposite angles. So what do vertically opposite angles mean? So if you have two lines like that, and let's name this 1, 2, 3, and 4. Angle 1 and angle 4 are vertically opposite to each other, right? So that means that angle 1 and angle 4 are congruent. They are the same. And angle 3 and angle 2, angle 3 is also congruent to angle 2. So vertically opposite angles are congruent to each other. Congruent to each other, which means they are the same thing. Let me give you a problem. So if you have something like this, and this angle is 50, and they say find the other three angles, so we instantly know that the angle opposite to it, this one, is 50, because they are vertically opposite. And you see that this whole thing makes 180 because it's a straight line. So 50 plus what is 180? 50 plus 130 is 180. So this is 130. And since this is vertically opposite to this is also 130. Now to confirm it, what we can do is we can add them all, and it should be 360 degrees. So 130 plus 130 is 260. 260 plus 50 plus 50 is 100. 100 is 360 degrees. As a full rotation is 360 degrees, which means that this is correct. So vertically opposite angles are just angles that are the same. let me give you another problem. So if you have something like that, and this was 110, so this is also 110, and this make 180. So 110 minus 180 minus 110 is 70. So this is 70, and since these are vertically opposite, this is also 70. You can confirm them by 70 plus 70 is 140. 140 plus 220 is 360. So that's vertically opposite angles. Now let's look at something called a median. Now to understand this concept, let's now draw a triangle. Let's claim this A, B, C. And let's have a line that goes from C to a point on AB and name this D. In this case, CD is the median. But what is a median? A median is a line segment that goes from one vertex of the triangle to the other side on the midpoint of it. So this would mean that the D is midpoint of the line segment AB. A median basically cuts the line segment into two equal parts. So line segment AD is congruent to line segment DB. Now, another thing that is similar to this is an altitude. What's an altitude? So it looks something like this. Let's use the same triangle. But in this case, D is not the midpoint of AB. These are not the same. But what it does happen is that they form right angle triangles here. So an altitude cuts the triangle so that it forms right angle triangles. You can also say that line segment AB is perpendicular to line segment CD because they form right angles when they meet. So an altitude is basically when they form right angles, and a median is basically when it cuts on the midpoint and forms congruent line segments of each other. Now the last thing that we are going to cover in this basic geometry lecture are the triangle congruency theorems. What does this mean? The triangle congruency theorems means that if you have two triangles, how do we prove that they are congruent, and how do we check that if they are or not? So there are 5 different methods that you can use depending on the triangles. So first of one is SSS, which means side, side, side. The second one is side, angle, side, which means side, angle, and side. Third one is angle, side, angle, which means that one angle, one side, and another angle. The fourth one is angle, angle, side, which means two corresponding angles and one side. And then we have hypotenuse leg, which is only for right angle triangles, which means if you have a hypotenuse and a leg that are same, then they are the same. Now let's look at each of these individually. Now the first thing we look at is side, side, side. So what does this mean, side, side, side? It means that if you have two triangles, let's say A, B, C, and D, E, F, then it means that if AB is congruent to DE, and EF is congruent to CB, and if DF is congruent to AC, then we prove that these two triangles are congruent. Let me give you an example with numbers. So if you have a triangle with 5, 6, and 7, and another triangle with 5, 6, and 7, let's label the points A, B, C, and A, B, C. This means that AB and AB, both of them are same, right? 5, 5. And AC and AC are same. And BC and BC are same, 6, 6. So that means that they are congruent to each other. Even if they are different, even if it is A, B, C, D, E, F, this still means that they are congruent to each other because the corresponding sides are same. Now how we write this is that triangle ABC is congruent to triangle DEF. DEF. The same orientation. First A, so first D. First E, then second E, then second B. Lastly F, and lastly C. It has to be the same orientation. You cannot say that triangle ABC is congruent to triangle FDE because they are not the same corresponding sides. A is not the same as F because this is 5 and this is 6. You see where I'm going with this? Side, 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 which means three sides. If two triangles have three sides that are similar, the same value, that means that they are congruent. Now let's look at side angle side. Side angle side. This means that if two sides and one angle in between those two sides, in between, it cannot be anywhere else, in between. For example, if I have two triangles and this side was 5, this side was 6, this side was 5, this side was 6, and if these angles were the same, only then this theorem applies and they are similar. Two sides, and it has to be in between them. It cannot be 30 here and 30 here and there are two sides and one angle is equal. That's not how it works. It has to be in between those two lines. So that is how side angle side works. If we have two sides and one angle that is inside those two sides, in between them, let's say A, B, and C degrees, and we have another triangle with A, B, and C degrees. Even if the orientation is different, we can see that the angle C is between A and B in both cases, so that this theorem applies, which proves that A, B, D, and let's say F, ABD is congruent to ABF because of the side angle side property that we used. Now let's look at the third theorem, angle side angle, which means that if we have two triangles and two angles in it, angle A and angle B, and a line in between those two angles, this one, C, line C. And we have another triangle with the same things, only then this theorem applies. It cannot be like if it has two angles on one side, it cannot be this angle, and this side. It has to be the side in between them. This angle, and this side has to be equal to this side for this theorem to work. I know this is a bit confusing and I'm not explaining it properly because I know I'm going a bit too fast, so if you want to rewatch this video, feel free to. Side, side, side. Let me just explain the other two a bit slowly. Side, side, side is if you have two triangles with the same sides, then they are congruent. Side, angle, side is if you have two triangles, side and angle and side, side, angle, side. The angle has to be in between those two sides for side, angle, side theorem to work. This is important. Angle between those two lines for this theorem to work. Now this third theorem, angle, side, angle. Angle, side, angle. This side has to be in between those two angles. So if you have two angles and ABC, what do you think? Which of these lines has to be the same for this theorem to work? C. Side C has to be the same because the side is between those two angles. So these two angles, the side between them is C. So that's why angle side angle works here if C is the same and these two angles are the same. Now let's look at the fourth theorem, which is angle angle. Now let's look at the fourth theorem, which is angle angle side, which means that if you have two triangles and two corresponding angles are equal with a side, then that means that they are the same. No, then that means that they're congruent. Sorry. And how is this different from angle side angle? Because in both cases, in both theorems, we have two angles on one side. Well, in angle side angle, we had two angles and the side was in between them. But in this case, we have two in angle side, we have two triangles, and the angles, the side length was not in the between, it was the other one. These are corresponding consecutives, so they're kind of the same, but they're not exactly the same, because in angle side angle, the side length is in between those two angles, and in angle side, the side length is one of the other two. It could be this one, or it could be this one, and these two are the same. A, B, B. Now the last theorem is hypotenuse length theorem. Hypotenuse leg theorem. Oops. Let me just erase this part. So now let's look at hypotenuse leg theorem. Hypotenuse leg theorem. And note that this theorem only works for right angle triangles. Oh, rat. That's funny. Right angle triangles. But what this means is that if you have two triangles, two right angle triangles, doesn't matter how they are orientated oriented. A, B, let's not label them right now. And if the hypotenuse is congruent and one of the legs is congruent, that is enough information to tell us that these two triangles are congruent to each other. So if you have a right angle triangle with hypotenuse 5 and other side 3, and we have another triangle with hypotenuse 3 and side length 5, are they congruent? No, they are not, because in this case the hypotenuse is different. You know which is congruent? 3, 5, 5, 3. These two triangles are congruent because the hypotenuse are congruent and one of the side length is congruent. So for hypotenuse leg, it is the hypotenuse should be the same and one of the legs should be the same. Let's go through all 5 quickly. Side, side, side is all sides are correspondingly same. Side angle side is that two sides are same and the angle in between them is same, not anywhere else in between. Angle side angle, two angles, and a side in between them is same. Angle angle side, two triangles, and the angles in between, and one of the side length is same. It's not in between, because if it was in between, it would be angle side angle, not angle angle side. You see they are next to each other. That's why it's AAS, not ASA. And lastly, hypotenuse leg only works for right angle triangles. Only works for rats. So hypotenuse is the same, and one of the leg side is the same. So these were the 5 triangle congruency theorems that you should be familiar with. And this concludes our lesson for basic geometry. If you like our video, please give us a thumbs up and share it around. The next topic is pre-algebra probably, so I'll see you in that. And if you have any questions regarding this, please pop a question in the comment section below. I'll reply to you as soon as I can. Until then, remember, math is fun.